So let's talk about functions. What is a function? Remember, a function is just a rule that has or that pairs an input with a single output. That's the basic definition. So it's a rule that pairs an input with a single output. The input, that's called domain, and the output is called romain. It's called range. That's just the math terms for it. Somebody named them. Usually the domain are just x values, the range are just y values. So it's domain and range. If you have, so let's look at an example of a function. There's a bunch of different ways that you can represent a function. One of them could be just a column, like two columns. So remember, a function is just a rule that pairs an input, the x, with an output. So in this function, 3 is paired with 3, 4 is paired with 7, 5 is paired with 7, and 8 is paired with negative 12. This is a function because 3 only goes to one, 3 only goes to one thing. 4 only goes to one thing. 5 only goes to one thing. And 8 only goes to one thing. So this is a function. What about something that's not a function? So if I had 3 going to 3 and to 7, and maybe 4 goes there, that goes there, that goes there. This now has two outputs. 3 has two outputs. One of them is 3, one of them is 7. That's not a function, just by the definition. A function is a rule that pairs an input with a single output. So something like this is not a function. Let's represent it in a different way. I could represent a function as ordered pairs. So this is what we have. It's actually the same function. I just wrote it using ordered pairs. 3 is paired up with 3, 4 is with 7, 5 is with 7, and 8 is with negative 12. That's still a function. They're just paired up. It just looks like a different, or it looks a little bit different, but it's the same. It's the same function. If I wanted to represent this with ordered pairs, I could. Remember, this is not a function. This is how you know it's not a function, because the x repeats. Remember, if the x is repeating and it has two different outputs, then it's not a function. I mean, you can only have one output for a single input. So a function is a rule that pairs an input with a single output. So this is still not a function because 3 is paired with 3 and 3 is paired with 7. The x repeats, so it's not a function. So that's another way to represent a function and not a function. I could represent a function with a graph. If I had this graph, if I pick an x value, I can draw it up, and it has a single y value connected to it. Anywhere I draw it, if I had an x value here, it would be paired with a single y value there. If I chose a negative x value, something like that, it has one single y value. So this is a function. It passes the vertical line test. So hopefully you remember, but the vertical line test says if you can draw a vertical line anywhere on the graph and it only crosses once, so I'm drawing this and it's only crossing once, only crossing once, only crossing once. If you can do that, then what you have is a function. If you can't do that, say you have something like this, if I draw a vertical line and it crosses more than once, then this is not a function. Again, we're continuing. The left side is a function, the right side is not. Something else that's not a function, well, it crosses 1, 2, more than once. Something else that's not a function, maybe something like this. It's not 1, 2, 3, 4. It's not a function. Something else that is a function. Let's do more examples of that. If I have something like this, If I draw a vertical line anywhere, it only crosses once when I draw the vertical line. So this passes the vertical line test. Oops, should extend. So all of this side is, or are functions. This side are not functions. So there you go. That's the functions review. Actually, let's see this. The domain are just the x values, right? So here, let me write down the domain. The domain would be 3, 4, 5, and 8. The range, this is for this problem. The range is just the y values, 3, 7. We don't need to write down 7 again, and negative 12. When you're writing down domain and range, you don't need to repeat. It's just the convention that we follow. Here, the domain would be 3, 5, and 8. The range would be 3, 7, and negative 12. Same thing. Except for this is not a function, so it's the domain and range of a relation, but we don't need to get into that. All right, I'm done with this one.